my students, in this presentation I shall be covering the principles of motion economy and some important principles which are used in design of the control and display devices. So, first of all I will be taking up the principles of motion economy. There are three main principles related to the motion of economy, which have been developed over a long period of time by the persons who have been working in the area of work system design, work study for improving the method so as to reduce the operator fatigue and the time required for carrying out the job. In industry, lot of work is carried out manually by the operators. So, if the method which involves the manual work is developed in such a way that it reduces the extent of movement and the movements are developed in such a way that it takes less time to the operator to complete a given job, then the productivity of the system can be improved. At the same time, the less fatigue will also be experienced by the operator during the operation. So, these principles related to the motion economy have been developed over a period of time based on the experience. These principles fall in three broad categories. These are related with the use of human body, the workplace arrangement and the design of tools and equipments. The principles related with the use of human body are related with the way by which the human body parts like hands, feet are to be used for effectively performing the job with the minimum effort and the minimum time, while the workplace arrangement is related to the design of the workplace in such a way that the given job can be done with the minimum effort by the operator and it takes less time, so that operator does not require unnecessary rest. Design of the tool and equipments, the principles related to the design of tools and equipments are also related with the designing the control devices and the display devices, tools, levers, handles in such a way that operator can operate them easily, effectively without much effort, and so as to reduce the time related with the operation for carrying out a given job. These principles will be covered one by one in detail. The principles related with the use of human body are, say, continuous curved motions should be preferred over the straight line motion, because more focused efforts are required for performing the straight line motion as compared to the continuous curved motions. So, as and when it is possible, continuous curved motions should be designed in the work method and they should be included suitably. Use to the lowest practicable classification of the body parts. The body parts like fingers and wrist, the finger, wrist and elbows, these have been classified according to the combination of their use, and this classification will be covered in the next slide. But here as much as possible, the lowest classification of the body parts should be used first, so that the related fatigue can be reduced. The lowest is the classification of the body part, minimum will be the fatigue experienced by the worker during the use. Both the hands should begin and end their motions simultaneously. The work methodology should be designed in such a way that both the hands remain busy and they should start and end their motions simultaneously, and both the hands should not be idle except during the rest periods. The methodology should be such that the hands should remain engaged and both the hands should not be idle in any case, except when the rest is being done by the worker to recover his muscles and overcome the fatigue. The hand motions should be symmetrical and simultaneously away from or towards the body. The movements of the human body parts should be designed, or the hand motion should be designed in such a way they are symmetrical and simultaneously carried out either towards or away from the body. So, these classification, as I have said earlier, that the classification of the body parts from 1 to 5 includes is like this, where classification 1 covers the fingers motion only, the classification 2 includes the finger and wrist motions, and classification 3 covers those motions which include finger, wrist and arms. All these 3 body parts are used in carrying out the certain motions. Those motions will be falling in classification 3. When the fingers, wrist, lower arm and upper arm is used for carrying out motion, then it falls in classification 4. And when finger, wrist, lower arm, upper arm and the trunk is also used to carry out the body motions, then it falls in classification 5 category. If the motion is carried out using the lowest possible classification, that is finger, then it will be causing the minimum fatigue, and the maximum fatigue will be experienced when the highest classification of the body parts are used for achieving a given motion. Some other principles related to the use of human body are like momentum should be used in assisting to assist the worker in carrying out the given job. If the momentum is used effectively, the efforts required by the operator to carry out the same job will be reduced, but in many cases momentum comes against the job which is being done, and in those cases momentum is to be overcome first manually, and under those cases momentum should be reduced to the minimum level if it is to be overcome manually by the operator during the job. And the middle finger and thumb should be used for handling the heavy loads, as these are the strongest fingers. So, work should be designed in such a way that the strongest fingers carry the maximum load, while the light loads for the light loads the index fingers, fourth finger and the little finger should be used. So, according to the capability of the fingers, the work should be designed so that either middle finger or thumb is used for the heavy work, while other fingers are used for the light loads only. Wherever possible, the use of feet should be encouraged, so that work can be carried out either simultaneously by both the hands and legs, or alternatively by hands and the feet, so that operator does not feel fatigue and work is also does not remain monotonous. The twisting motions should be performed with the elbows in bent condition. The next principle in the principles of motion economy is related with the design of workplace. The workplace is to be designed in such a way that whatever the tools, equipments, raw material is to be used, the same can be easily effectively used by the operator with the minimum effort and the fatigue. The workplace should be designed keeping in mind certain aspects, like fixed location for each tool and material should be provided, so that it will not require unnecessary searching and the selection related steps, because lot of time is consumed in finding the desired item and then to get it for carrying out the further operation, either assembling or further processing of the raw material or using the tools for further processing. So, fixed location should be provided for each tool and the material, so that the unnecessary search and the select related steps can be eliminated. And the gravity bins and drop deliveries should be used to reduce the reach and the move related items. These are other steps which can be reduced by encouraging the use of gravity bins and the drop deliveries. All materials and tools should be located within the normal working area. If the distance of the tools and the materials to be used from the body is increased, then it will simply increase the efforts which are to be carried out by the worker. That is why the material and the tools are to be located and placed in such a way that operator can use them easily with the coverage of the minimum distance, and that is why these should be located within the normal working area, so that worker will not be required to put unnecessary extra effort for carrying out the job. This should be as close to the point of use as possible. The places for tool and work material should be as close to the point of use as possible, so that distances to be covered by the material can be reduced, and so that the fatigue of the operator related with the handling of the tools and the raw materials can be reduced, and the total time of the operation also can be reduced. So, if these are placed as close to the point of use as possible, it will reduce the operator's fatigue, and the time required for carrying out the job also is reduced. Some other points related with the design of workplace, like work table height should allow the alternate sitting and the standing posture, so that the fatigue being caused by the work to the operator can be relieved with the alternate sitting and the standing posture during the work. So, work table height should be such that it permits the use of alternate working in standing and sitting positions. The glare free, adequate illumination, proper ventilation and the proper temperature should be provided, so that operator can work comfortably without unnecessary feeling anxiety or experiencing the fatigue and the pressure due to either excessive glare or the poor ventilation or excessive high or low temperature. So, these good working conditions should be provided, so that operator can deliver his best with the minimum fatigue and can produce the desired goods. The control and the display devices should be designed in such a way that operator can use them easily and effectively without any error. So, and the principles related with the design of control and display devices will be covered in detail later on, but these devices should be designed in such a way that they can be used easily, quickly, without any error. The third principle related with the use of motion economy is related with the design of tools and equipments. The design tools and equipments should be designed in such a way that they need minimum attention of the worker and they need minimum effort from the operator during the operation. And for this purpose, the use of proper coding of the control devices in the tools and equipment should be there, so as to maximize the speed of work and minimize the error during the operation. Inefficient coding, improper coding leads to the accidental wrong use of the control devices, which simply leads to the sometimes accidents or poor quality of the jobs. That is why the proper coding of the control devices is important to maximize the speed of the work and minimize the errors related with their operation. So, all levers, handles, wheels and other control devices should be located in the most preferred places, so as to use the mechanical advantage. The devices which are to be operated by the worker should be located in such a way that operator can use them with the mechanical advantage where less efforts are required to carry out the same job. So, the location will decide the extent of the mechanical advantage is being used in their operation. Efforts should be made to locate the devices and the levers and handles in such a way that they need less effort and less force to operate them, and that is possible by using the mechanical advantage related factor in after a proper location. Some other points related with the design of the tools and equipments are like use of jigs and fixtures to hold the tool raw material and for guiding of the tool should be used. Fixtures reduce the time required to hold the workpiece in proper position, and they also reduce the efforts required for holding of the workpiece, while the use of jigs reduces the time and efforts required for holding the workpiece and also guiding the tool in proper position where it is required. The role of fixtures is mainly to hold the workpiece, while fixtures in addition to holding the workpiece also guides the tool in the position where they are required. So, use of jigs and fixtures will not only reduce the efforts required for carrying out a given job by the operator, but will also save a lot of time. Use of stop guides to reduce the unnecessary manual controlled positioning. Stops should be used as and when it is possible, so that manually it will not be required to start or stop or control the motions as per requirement. The systems will automatically respond if the stop guides or stops and guides are used, and that will help to avoid the unnecessary manual controlled positioning of the tool or of the workpiece during the operation. Some other principles related with the design of tools and equipments are like the design of workplace layout should be done keeping in mind some of the following points, like height of the workplace should be determined in such a way that that it allows the working of the operator in a standing and the sitting positions alternatively, and the operator is able to sit on the chair comfortably for long time as required. The design of the operator chair, if work is to be done in the sitting posture, should be such that it can be used by the operators of the different heights. So, for that purpose it may have the provision for adjustment of the height of chair. So, that kind of chairs and such kind of chairs are frequently used in the computer centers, where people of the different heights can use those chairs for the operations required. So, the adjustable range design of adjustable range features is principle is used for designing such kind of chairs, and allow the use of anti-fatigue mats for standing of the operators, so that related fatigue can be reduced, and the determination of the location of tool, materials, control display devices in such a way that the operator can use the tools and the materials with the minimum effort and fatigue, and at the same time error free and easy control is possible with the proper designing and location of the control and display devices. For location of the tools and the controls, as we know that with the increase in distance of these tools, materials and the controls from the body, the distance to be moved by the body member increases. So, increase in distance of the body member movement during the work increases the muscular effort, the control and the time required for carrying out the job, and that is why the tools, materials and the controls should be located in such a way that the distance of the body member movement during the work is minimum, so that the related muscular effort, control and the time required can be reduced, and therefore, tools, materials and controls etc. should be located within close reach of the operator. The location of the tools, materials and controls is decided in light of the anthropometric data of the operator or the group of the operators, and that is based on the normal working area concept and the maximum work area concept. The figure in the next slide will show what is the normal working area. Normal working area is one where the area which can be covered by the hand without stretching the whole arm, while the maximum area includes the area which can be covered by stretching the full arm during the work. So, these areas can be seen in the horizontal plane also and in the vertical planes. So, for a group of people, average normal working area and the maximum working areas have been identified. You can see in this slide shows the arm when it is in fully stretched and arm is not stretched, upper arm is in the normal condition and only the lower arm portion is stretched. So, the area which is covered by the stretching of the lower arm only up to the fingers on both the sides comes under the category of the normal working area. Here, if you can see here from this elbow to this fingertip, this entire area which can be covered by this right hand and the area which can be covered by the left hand indicates the normal working area, while this is the distance of the maximum possible reach of the hand when arm is fully stretched. It is of say about 60 centimeter, and when it is fully stretched, this entire area, this radius indicating the entire area which can be covered when arm is fully stretched. This area is termed as the maximum working area, and this area is for the left hand, maximum working area for left hand, and this indicates the maximum working area for right hand. The normal working area for normal working area is in the radius of the 40 centimeter and the maximum working area in radius of 60 centimeter, and the 30 centimeter is considered as average width between the two hands. What we have seen was the horizontal in the working areas in the horizontal plane. Now, we can see the working area in vertical plane. Here, from the shoulder to the maximum stretch of the hand is of 70 centimeter, the maximum for extended arm indicated by this will be the maximum working area, and here it is of 42 centimeter in the vertical plane indicating the normal working area. Normal for forearm and the maximum for extended arm is of 70 centimeter. So, effort should be made first to locate the tools and the devices in the normal working area first, so that the tools and the raw materials will be as close to the body as possible, and thereafter the things which are less used and needs less effort can be located away from the body and they can be located in the maximum working area region. Location of the control and display devices for effective utilization is very important, because if these have been located in such a way that either operator cannot operate them effectively or cannot operate them in such a way that what result he is going to get, or he is not able to see the kind of results which are being achieved through the display devices, then that indicates that the control and display devices have not been located properly. The control the control and display devices should be located in relation to each other, so that when control device is operated, operator is able to see that what kind of response he is getting by giving the inputs through the control device. And it is important that control devices and display devices are located in such a way that he can see response, so that the control devices can be operated easily, and quickly they are identified and they are operated easily. Easy identification of the control devices is important for easy operation. At the same time, to reduce the operational error in emergency situations, it is necessary that what kind of response he is getting by when control device is adjusted through the display devices. Display devices giving the status or the kind of change which is taking place with the change of control through the control devices. So, to locate the control devices, the best possible area is selected. The control devices and display devices are located in such a way that when control device is operated, display can be seen in the display device. That is the first thing. And when the control devices are to be located, some of the points are kept in mind, like what kind of performance of the operation which is being controlled, the kind of human sensation required for controlling the things, and the anthropometric aspects required in locating the things properly, and the biomechanical features of the body, means the kind of movements and the forces required for operating the control devices. So, these consideration of these 4 factors will help in locating the control devices in optimum manner. Performance will indicate the criticality of a particular control in success of its operation. Human sensation will indicate that which kind of how the body will be getting the sense when the device is operated, control device is operated, like touch is to be used, or just means by seeing it, it will be used, or by hearing it will be used. So, anthropometric data indicates that what is the maximum range or the minimum range which can be covered if it is located at particular place, and what is the average anthropometric data of the human being which can use a given control set of the devices or the display devices. Biomechanical feature indicates the kind of forces, speed of movement, accuracy of movement which is possible by the body part which is to be expected to perform for controlling the device. So, these 4 factors are considered for locating, for identifying the optimum area, and in that optimum area the control devices will be located. So, based on the consideration of our 4 factors, a best possible area is identified for a group of persons for a group of the tools. In general, these are the general points which helps to find out the best possible space for locating the control devices. Like visual display should be located 10 degree below the horizontal of the human being sight level, and it should be at 10 to 15 centimeter radius. The optimum location for hand control should be within easy reach of the hand, and based on the above consideration a general area is selected. So, how to use the best possible area which has been selected for locating the different control devices which are available, for locating in optimum manner. certain principles are used based on which the control devices are located in the best possible area, and these principles are for related with the location of the control devices are importance are based on importance, the frequency of use, the sequence their functions and the sequence of operation. So, the control devices should be located in light of these 4 principles. These are the importance, frequency of use, functions which are performed by the different controls and the sequence of their use. So, based on the importance, the control devices may be in use of the different types. Some of the control devices may be used just to switch on and switch off the things, and some of the control devices may be there to regulate the speed, feed, depth of cut or to achieve any specific function. So, the functions depending upon the criticality of the functions, control devices are located as per needs. So, the most based on this principle of importance to locate the control devices, the most important items or group of items is located first within the normal working area in the best possible position. The most importance is given to those which are very important for the smooth functioning of the process. So, the most important controls will be placed in the normal working area in the best possible positions first, and thereafter other items or group of items is selected and located within the other areas which are left. So, the next important component, an item or group of items is then selected and located in the best location within the remaining area. So, according to this principle, the optimum use of the best possible space is decided on the basis of importance of the particular control device. The second factor which is also used for deciding where the controls are to be located in the best possible area, that is the frequency of use. According to this principle, the controls which will be used to the maximum level and with the maximum frequency, they are located first in the best possible area. So, the items with the greatest frequency of use has the highest priority for location at the optimum position, while the remaining items are located in the remaining area using the same principle. So, according to this principle, control devices are located on the basis of the frequency of their use. The another principle which is used for locating the control devices is that function. The control devices which are used for performing the similar type of the functions are grouped at one place. So, grouping of the items according to their functions is done according to this principle. Like all control devices functionally related may be grouped together and located at one place. For example, if some of the control devices are used for increasing or decreasing the speed or feed, then they will be grouped at one place. Like on off controls are grouped at one place. So, the devices which are of similar type in nature of their function, they are grouped at one place, so that operator can use them effectively without making extra efforts to identify and locate them where they are, so as to use them. Some of the examples are like feed and speed controls are located at one place, are grouped in one category, switching on and switching off the systems also placed at one place. The another principle which is used for locating the control devices is the sequence of use. Some of the control devices are used in one particular order of the items that are located items according to this principle are located according to use of their sequence. For example, an assembly is made by assembling the sub assemblies in a specific order. In the same way, if the control devices are to be used in sequence, then accordingly they may be located either from the top to bottom or bottom to the top, or left to right or right to left. So, based on the sequence of use, the control devices can be located. From the motion economy, it is important that the sub assemblies are located in the sequence of their use, but sometimes it is not found very effective, because sequence of use may not lead to the most effective motion, or it may lead to the excessive time required for search and select the items which are to be used during the operations. However, from the principles of economy point of view, it would be better if the controls and sub assemblies are located in the sequence of their use. So, this is the point, that for better economy and better economy of the work, and for increased productivity, it is important that all location of all tools, materials and the controls be fixed in such a way that the search and select is minimized. It is not necessary that the control devices should be located only in light of the principles of motion economy. It should also be seen that the control devices, tools and materials are located in such a way that the search and the select related activities can be minimized, so that the time required for carrying out the job can be reduced and the operator efforts also can be reduced. And therefore, the engineering systems which will be used by the worker while carrying out the job should be designed in such a way that it needs the less effort from the operator for performing the desired job. For designing the mechanical systems which will be used by the worker during the operation, should be for designing the systems which will be used by worker during the operation should be based on the anthropometric aspect of the worker, which who will be operating the mechanical systems. For designing the mechanical systems, some of the points are kept in mind, like what are the important and the relevant body dimensions. Like the mechanical system will be operated by the which part of the body, whether feet will be used or hands will be used, knee or toe will be used. So, according to the type of the body part which is required to operate the mechanical system, the dimensions of the body parts are kept in mind while designing a mechanical system, and defining the relevant population who will be using a given mechanical system. Like mechanical systems can be used by the variety of the people, like a chair can be used by the adult, by the army man, by woman or by the KG childrens. So, for the different group of the people, since the anthropometric data is different, so if the population, targeted population for a given mechanical system is defined properly, then it will help to get the idea about the range of the dimensions which can be there as far as height, length or the weight is concerned. So, after defining the group of population and the important body dimensions which are required to be used in operation of the mechanical system, these are used in designing of the mechanical system. Like defining the population helps to establish the dimensional range that can be considered in design of the mechanical system. And once the data about anthropometric data about the targeted population has been received, and the average and the dispersion of the data has been obtained, what principle is to be used is decided. The mechanical systems which can be used by the general public should be designed using the three can be designed using three different types of the principles. These principles are designed for extremes where it is kept in mind that what is the maximum or the minimum dimensions of the individuals who can use a given mechanical system. So, design for extremes is based on that what is the maximum possible dimension of the human body part who can use the given system. On the other hand, the design for adjustable range is if the design for the adjustable range principle is used for designing the mechanical systems, then it allows the use of the mechanical system by the population having wide range of the anthropometric data, like if the people of the smaller height can use the one chair, then the people of higher height can also be used the same chair by adjusting its position. So, that adjustable range feature is included in the systems, mechanical systems like the computer chairs and the bicycles, where the people of the different heights can use the mechanical systems which are being designed by the organization. The design for average, this principle of the design for mechanical systems is used when there is no specific group of the population who can use a mechanical system, like a tap or the location of the switchboard in public place. The switchboard or tap in public place can be used by a small kid also, by children, by adult person, or means the variety of the people can use a given device under those conditions. The design for average is used, which indicates that that this design will not be optimum for anybody, but it will cause the less inconvenience to all those who will be using the given mechanical system. So, in designing of the mechanical systems, the three principles are basically used. So, which of these three principles is to be used for designing a given mechanical system, decision on that is taken whether a component or the mechanical system is to be designed for the extreme people with the extreme anthropometric features, or the people for people with the variety of the anthropometric data, or the people where entire range of the people who can use a given mechanical system. So, other steps which are there in design of the mechanical systems using anthropometric data are like deciding the percentage of population which is to be accommodated. Like this principle is considered, means this percentage of the population is decided in case of principle for extremes and principle for the adjustable range. The range, adjustable range is decided in such a way whether 95 percentile of the people will be covered, or 90 percentile of the people will be covered, or 99 percentile of the people will be covered by a given adjustable range. It becomes uneconomical to design a mechanical system covering the 100% range of the people with the wide variety of the anthropometric data. It becomes uneconomical because the with a very narrow range with very narrow adjustable range of the features, most of the people are covered. For example, like 10% adjustable range or 10 centimeter adjustable range can accommodate the 95 percentile people, while 15 centimeter adjustable range may be required in a bicycle for 99 percentile of the people, while 100% of the people, 100 percentile of the people coverage needs a adjustable range of 26 centimeter. So, unnecessary increasing the adjustable range will increase the cost also, but which may not increase the significant percentile of the people who can be accommodated using the adjustable range. So, what is the percentage of people population to be accommodated by the given design, regarding that decision is taken first, and then anthropometric data is obtained from the record, and the central tendency of the anthropometric data which is of use for a given design, and it is spread in form of range or standard deviation are calculated, and if required suitable allowances are also considered in designing of the mechanical systems, say like thickness of the socks in design of the shoes is considered, or cloths thickness is considered in designing of the relevant items. So, here designing for control and display devices, there are many important things which are kept in mind so that the operator can use them effectively without much error. A control device is a control is a device that transmits the signal into a system or the mechanism. For controlling a given mechanical system, the devices are used and which transmits the signals to the system or mechanism, so that the systems respond in different way. So, a control device is basically a control is a device that transmits the signal into the system or the mechanism, so that it changes its response as per need of the information to be transmitted. The different forms of the control devices are used to perform the desired functions. For example, like the push buttons, toggle switch, knob, thumb and hand wheels and the keyboards are typical control devices. When these are operated, system responds to when these devices are operated. Most of these are these control devices are activating the system, while the keyboard is mainly used for entering the data in the system. For efficient use of the control devices, it is necessary that these are identified by the worker easily, and so that the required function can be performed. To avoid the use of wrong controls, it is necessary that these devices are easily identified and recognized by the operator during the operation, while otherwise if the operator is not able to recognize these control devices easily, then it can lead to the inefficiency, accidents and continued wrong use may lead to the frustration in use of the control devices. That is why the control devices should be designed in such a way that they can be recognized easily to reduce the set problems and for having the improved performance, proper control recognition system should be used in design of the control devices. This can be achieved by use of the proper coding of the controls. Various methods have been developed over a period of time for coding the control devices. These methods are based on like shape and texture coding. Means different types of the coding methods are there for control devices. One is shape and texture coding, locational coding, size coding, color coding and level coding. Each coding method has got its own advantages and the limitations. So, depending upon the anthropometric data and the working conditions, the strain conditions or the working conditions in which a worker is working during the operation, all those are kept in mind while selecting any of these coding method for control devices. So, we will cover first the shape and texture coding method. The desirable feature of this coding method for control device is that it can be used for low illumination conditions, and the touch operation is possible. Undesirable features of location coding methods are limited number of controls can be coded, more space requirements, and identification of the control is not certain by this method. So, these unlimited feature, these are the undesirable features related to the location coding method. The size coding also has the desirable features like the low illumination conditions. Under the low illumination conditions, this method can be used and touch operation is possible, and the limited number of controls can be done, can be coded by this method. More space is required in size coding for coding the number of for coding the controls, and identification of the control is also not certain in size coding, especially when gloves are used. Color coding is useful for visual identification, and the moderate number of controls can be coded by this method, but it is necessary that the codes are viewed directly, and the good illumination conditions are there, and adequate color vision of the operator is also needed for successful use of the color coding. For selection of the optimum color optimum coding method for controls depends upon the number of controls which are to be covered and included in the given area, and the available panel space is to be seen, the level of illumination available in the working conditions, and the operator's workload. This indicates the mental and the strain conditions of the worker. So, these points are kept in mind while selecting the coding method. The criticality of the control function is also kept in mind, like any error in the operation of the control function can lead to the accidents or severe economic losses also. So, these points are kept in mind while selecting the proper coding method. The control and the display ratio is the one important parameter which is used in design of the control and display devices. The control and the display ratio indicates the sensitivity of the control device. When a small movement of the control is required to give the large movement of the display, then we have the low control to the display ratio. The control to the display ratio indicates the distance of the control movement to that of the display movement is called control display ratio or C/D ratio. The low control and display ratio results in a small control movement will produce the large movement of the display movement, and which in turn allows the gross adjustment, but it becomes difficult to achieve the precise setting using the control and display device which offers the low C/D ratio. On the other hand, high C/D ratio permits results in the large control movement for a small display movement, which allows the precise setting for achieving the desired function. So, the C/D ratio is very important in designing the control and display devices. Low C/D ratio is used when gross adjustments in the readings or the control settings are required, while the high C/D ratio is used when precise settings are to be used or very accurate setting is required. The display devices are those devices which are used to show the information about the status of the system. The system may be in a static or the dynamic condition. The different types of the display devices are used which may give the data in form of quality or the qualitative data, like the display devices which are used typically in the fan regulators, that in where we find either 1, 2, 3, 4, 5 in the fan regulators actually does not indicate the speed of rotation of the fan. It is just symbolic that is when the control position is changed, it affects the speed of the fan. 1 is for minimum, 2 is for somewhat higher, 3 is for further higher. So, the qualitative the display devices where the numbers or the alphabets being used does not represent the actual value of anything. The quantitative data will be showing the numerical value of the different characteristics, like pressure being pressure is indicated in terms of the kg per centimeter square, or the temperature is shown in degree centigrade per degree centigrade or degree Fahrenheit. The status of the system means the status of the system can be shown by the display devices in form of the red or green signals in the operation theater, where red indicates that the operation is going on, and the warning is indicated by the presence of the red signal or some sort of the siren. Identification is shown by the color codings, for example, railway signals in the railways. The representation display where symbols, charts and the diagrams are used to show the things desired. Alphanumerics are also used to display the things in form of the signboards and the placards. Now, I would like to summarize this presentation. This presentation we have seen that there are three principles which are commonly used for designing the workplace, for use of the human body, and for designing the tools and equipments which are to be used by the operator during the work. And at the same time, we have also seen that the different principles which are used for designing the control and the display devices. Thank you for your kind attention.
Thank you.